used to keep messages secret? Well, one method that we can use is to use an encoder on one side and a decoder on the other side. It's then up to Alice and Bob to define these encoder-decoder and then to keep that secret. As long as Eve doesn't know what the algorithm is, then Bob can encode his message in a secret form. We typically call this a ciphertext and this a plain text. Pass it, and Alice knows how to decode it. One of the first examples of this was the Caesar code. With the Caesar code, the letters of the alphabet are moved a certain number of spaces. In this case, we can see the letters have been moved 2 spaces to the right. So the message that comes out is encoded in some way. So in this case, R, capital R, is a T, and F is an H, C is an E, so we see the first word is the, a Z is a B, so the boy stood on the burning deck should be the message here. To our eyes, this seems a fairly simple code, but at the time it was fairly secure. Overall, as there are 26 letters in the alphabet, there are only 25 code mappings, so it's fairly simple for someone to be able to decode this message. A more advanced version is to scramble the alphabet up. In this case, the letters have been scrambled, so a Q in this case is a T, a B is an H, a C is an I, and a T looks like it's going to be an S. A T is somewhere. T is an S up here. And the advantage with this is that we now have 4 and 26 zeros. So it's 403 million billion codes. So it looks as if this is a fairly secure coding system. Unfortunately, the English alphabet has a varying probability for each of the letters. For example, an E is the most probable, and in UK English, a Z is the least probable. Along with this, there are 2-letter occurrences, 3-letter occurrences, and words. So it is then possible to look up the probabilities of each of the letters and then to try and match them with the cipher code. So in this case, we probably would find that the letter E in this case is coded as an A, so we can see it is a highly probable letter, so we could probably guess that that was an E. So that method suffers greatly in that the probability is seen inside the actual ciphertext. An improved method is one that has a moving mapping. In this case, we define a secret key code, in this case green, so then the mapping will move around from G to R to E, E again, and then to N. So the mapping will go, in the first case, from A to this line here. So an A would be mapped as a G, and so on. So as we build this up, the first letter here is an H, and we go to row G, which is this row here, and that gets mapped to an N. Next, we have an E, and the row is R, so we have a V here. Next, we have an L, and we're on the E row, so an L in this case becomes a P, and so on. So this is an improved method of reducing the the standard occurrences of letters. It's not perfect because it will recur. An improved method on this is to map each of the letters to certain codes. The higher the probability, the more codes that will be used for the letter. So in this case we can see that E has many codes associated with it and Z has very few. Each time an E occurs, a new code or a different code is taken for it. 25 first time, 26 second time, 28. So it will now be very difficult to analyse the numbers that appear, as they should all be equally probable.